When you hear on the news that there was a magnitude 5 earthquake,
a 5.2 magnitude quake,
a 4.3 earthquake, a magnitude...
That magnitude estimate actually comes from the Berkeley Seismological Lab, and this is the actual data through our partners, the US Geological Survey, who then deliver that information to the news media. People often ask me, so why did you move to California? And for me, I literally moved here for the earthquakes.
Magnitude 3.1, and it happened on Cal's campus.
This is the highlight for me, is actually being here on the Berkeley campus. Not only are we running a seismic network, but of course we are right on top of the Hayward Fault, the most hazardous fault in Northern California. We really are tackling a problem that one day is going to be a major factor for everybody who lives in the East Bay. For me, that's a real value of being here at UC Berkeley. Here at the Berkeley Seismology Lab, our special sauce is the fact that we have all these different types of people all in one place. We have students every single year with brilliant new ideas. We have a very professional staff that are running the seismic network. So the seismic network consists of seismometers, which are metal cylinders that we bury in the ground, connect it to a computer that records the data and transmits the data to us so that we can process the data and understand when earthquakes are going on and issue these warnings. But this seismic network, it's across the entire state, from urban environments, because we need to detect earthquakes when they're right beneath the cities, but also in remote places like the Farrell Islands, where we have a broadband instrument on the Farrell Islands, so if there's an earthquake that starts offshore, then we can also detect that very rapidly.
Earthquake.
The shake alert could give you a few precious seconds to react before you feel the shaking.
Probably one of the most impactful things that we've been doing over the last few years is the development of an earthquake early warning system. And so this is a system that uses the same seismic network that we use to detect all earthquakes, but this time we do it really fast, and then we estimate whether somebody's going to feel shaking in a different location, and we push a warning out.
Drop, cover,
using what we call the MyShake app. This is a free app that you can download on your iPhone or your Android phone. So how can people use that? Well, as an individual, you can use it to drop, cover and hold on, but also people use it on a larger scale. The trains, the BART system in the Bay Area, for example, they slow and stop their trains to prevent the likelihood of derailments. Schools use it to issue a warning and reduce the likelihood of injuries. Firehouse doors open, elevators get to the nearest floor and open their doors. All of these strategies are used to reduce the likelihood that you're going to be injured in an earthquake.
We have had a very, very powerful earthquake that first struck at about 4:31 this morning.
Now, the total estimated cost of just the injuries in the Northridge earthquake was $2 to $3 billion. So just the monetary value of having everybody protect themselves way outweighs the cost of the system to start with. But in addition to that, if we have 0 trains derailing, people in cars are notified there's an earthquake, they start to slow down. If people put data into safe storage, then the monetary value of early warning systems is really huge. Whenever I tell somebody I'm a seismologist at a party or something, they immediately ask the exact same question. When's the big one going to occur? And of course we can't predict earthquakes. Most people know that we can't predict earthquakes. But despite that, we can understand how frequently we expect to have them, and we can understand what the likely impacts are going to be. And those are the strategies we can use to reduce their impacts. One of the things I learned early on as a seismologist is there is not a lot of money in seismology. As in, people are not really willing to pay for these kinds of products, even though people really value getting the alerts when they get them. So if we didn't have public funding in a university environment, I don't think we would have had the development of an earthquake early warning system. That's where the value of both public funding and universities really come into play.